Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This lesson, the dot product, is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended to view the video Introduction to Vectors prior to watching this video. In this video, we will discuss the definition of the dot product, the angle between two vectors, orthogonal vectors, and expressing a vector using magnitude and direction. If v equals v1i plus v2j and w equals w1i plus w2j are two vectors in a plane, then the dot product v times w is defined as v times w equals v1 times w1 plus v2 times w2. If v equals v1i plus v2j plus v3k and w equals w1i plus w2j plus w3k are two vectors in space, then the dot product v times w is defined as v times w equals v1 times w1 plus v2 times w2 plus v3 times w3. Note that the dot product of two vectors is a scalar product. For example, find the dot product of the following vectors. V equals 2i plus 4j, and w equals 6i minus 7j. V times w equals v1 w1 plus v2 w2. Fill in the numbers to get 2 times 6 plus 4 times negative 7. Simplify to 12 minus 28, or negative 16. In another example, v equals 3i minus 2j minus 4k, and w equals I plus 3j minus 2k. In the case of a vector in space, v times w equals v1 w1 plus v2 w2 plus v3 w3. Fill in the values to get 3 times 1 plus negative 2 times 3 plus negative 4 times negative 2. Simplify to get 3 minus 6 plus 8, which equals 5. The following theorem states that the angle theta, where theta is between 0 and pi, between two non-zero vectors v and w, is given by the formula cosine theta equals the dot product of v times w divided by the magnitude of v times the magnitude of w. For example, find the angle between the following vectors. V equals 2i plus 4j and w equals 6i minus 7j. The cosine of angle theta equals the dot product of v times w over the magnitude of v times the magnitude of w. The dot product of v times w was previously calculated as negative 16. The magnitude of v equals the square root of 2 squared plus 4 squared equals the square root of 20 and simplifies to 2 times the square root of 5. The magnitude of w equals the square root of 6 squared plus negative 7 squared, which equals the square root of 85. We then fill in these numbers to get negative 16 over 2 times the square root of 5 times the square root of 85. This simplifies to negative 16 over 10 times the square root of 17. To find theta, we take the arc cosine, which calculates to approximately 1.97 radians, or approximately 112.83 degrees. Let's start with the same formula. Cosine theta equals the dot product of v times w over the magnitude of v times the magnitude of w. If these two vectors are perpendicular, then the angle theta is 90 degrees, and cosine 90 degrees is equal to 0. In this case, the two vectors v and w are perpendicular, also called orthogonal. The following theorem states that two non-zero vectors v and w are orthogonal if and only if the dot product v times w equals 0. As an example, find the dot product of the following vectors. V equals 2i plus j plus 4k, and w equals 3i plus 2j minus 2k. V times w equals v1 w1 plus v2 w2 plus v3 w3. Fill in the values to get 2 times 3 plus 1 times 2 plus 4 times negative 2. Simplify to get 6 plus 2 minus 8, which equals 0. Therefore, the two vectors are orthogonal. Let v equal v1i plus v2j plus v3k be a non-zero vector in space. Then let alpha be the angle between the vector and the x-axis, beta the angle between the vector and the y-axis, and gamma the angle between the vector and the z-axis. This makes cosine alpha equal to v1 over the magnitude of v, cosine beta equal to v2 over the magnitude of v, and cosine gamma equal to v3 over the magnitude of v. We have previously established that the unit vector for any vector in space is equal to v1 over the magnitude of vi plus v2 over the magnitude of vj plus v3 over the magnitude of vk. We can then substitute the cosine values to get cosine alpha I plus cosine beta j plus cosine gamma k. From this, we conclude that if v equals v1i plus v2j plus v3k is a non-zero vector in space, then v equals the magnitude of v times the quantity of cosine alpha I plus cosine beta j plus cosine gamma k. As an example, find the magnitude and direction cosines of the following vector, and write v in terms of its magnitude and direction cosines. V equals 2i minus 4j plus 5k. The magnitude of v equals the square root of 2 squared plus negative 4 squared plus 5 squared. Simplify to get the square root of 4 plus 16 plus 25, which equals the square root of 45. This can be simplified to 3 times the square root of 5. Cosine alpha equals v1 over the magnitude of v, or 2 over 3 times the square root of 5. Cosine beta equals v2 over the magnitude of v, or negative 4 over 3 times the square root of 5. And cosine gamma equals v3 over the magnitude of v, or 5 over 3 times the square root of 5. V equals the magnitude of v times the quantity of cosine alpha I plus cosine beta j plus cosine gamma k, or 3 times the square root of 5 times the quantity of 2 over 3 times the square root of 5i minus 4 over 3 times the square root of 5j plus 5 over 3 times the square root of 5k. An airplane flying due north has a true airspeed of 500 knots. There is a northwesterly wind of 60 knots. Find the ground speed and direction of the ground track. Northwesterly is defined as midway between directly north and west, or 45 degrees to the left of the aircraft's heading. When related to the positive x-axis, this becomes negative 45 degrees. We set the airplane heading as 500j and the wind heading as 60 times cosine of negative 45 degrees I plus sine negative 45 degrees j. The cosine of negative 45 degrees is the square root of 2 over 2. Sine negative 45 degrees equals negative square root of 2 over 2. This simplifies to 30 times the square root of 2i minus 30 times the square root of 2j. Therefore, the velocity vector of the airplane with respect to the ground is v of g equals 500j plus 30 times the square root of 2i minus 30 times the square root of 2j equals 30 times the square root of 2i plus the quantity of 500 minus 30 times the square root of 2j, which calculates to approximately 42.43i plus 457.57j. The magnitude of v of g equals the square root of 42.43 squared plus 457.57 squared, which calculates to approximately 459.63 knots. To find the ground track, we first understand that the value 42.43 is a change in x and 457.57 is the change in y. If we establish the angular change in ground track as theta, then tangent theta equals delta y over delta x, or 457.57 over 42.43. The change in ground track is then theta equals the arctangent of 457.57 over 42.43, which equals approximately 1.48 radians, or 84.7 degrees with respect to the x-axis. This equals a change in course of approximately 5.3 degrees east of the northerly heading.
If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.